At this point, we've talked about a variety of strategies for evaluating limits. So given any particular problem, we're going to need to know which of those strategies we're actually going to use. So I want to look at a couple examples here where the denominator is approaching zero and how that's going to affect how we approach that problem. So in this particular problem, if we try direct substitution first, we always want to see what happens if we just plug 2 in for x in a problem like this. What we get on top is that value is approaching 8, and on the bottom, the value is approaching 0. And if we take 8 divided by 0, we get an undefined value. So undefined is not ever going to be an answer for a limit. We might say the limit does not exist, but we're not going to say it's undefined. And so 8 divided by 0 doesn't give us an answer that makes sense for a limit. So what I'm going to do here is I'm going to analyze this on each side. So I want to see what happens as we approach 2 from the left of this function. And then I'm going to do the same thing as we approach 2 from the right. So as we approach 2 from the left, let's think about what that does to the top and the bottom. That's different from what we did up here with just direct substitution. So what that means is we're plugging a value in for 2 that's just a little bit smaller than 2. So like 1.9 or 1.99. So we're getting really close to 2, but it's just a little bit smaller. So on top, we take a number that's smaller than 2 and square it. We get a number that's smaller than 4. So the top is approaching 8, but it's going to be a little bit smaller than 8. So just to be clear, this is a positive 8. I'm not going to put the positive sign there, but it is a positive 8, but it's a number a little bit smaller than 8. Okay. On the bottom, if we plug in a number a little bit smaller than 2 and then subtract 2, we're going to get a number that is really close to 0, but a little bit smaller than 0. This time, since we're at 0 and we go a little bit to the left, this actually is a negative number here. And this is going to be really important in actually evaluating this limit. And the reason is, if we take any number that's not 0, so the 8 here, and we divide it by a number really close to 0, so think 8 divided by 0.1 or 8 divided by 0.01, the closer we get to 0, the bigger the number is. And that's going to get bigger and bigger and bigger, and there's not going to be any bound to it. So what that means is this limit here is going to be infinite. However, remember the denominator approached a negative value close to 0. And what that means is we're taking a positive divided by a negative, and we're actually getting really big negative values for that. So since the denominator was approaching 0, but it's a negative, then we get negative infinity. Had this top number approached a negative number, say negative 8, let's say it was negative x squared minus 4, and then we were approaching 0 from the left down here, a negative divided by a negative is going to give us a positive infinity. All right, so let me back that up here because that's not what's happening here. So let's look at what's going on the other side then. So the limit as x approaches 2 from the right. Now, if you remember, I said the numerator was approaching 8, but a little bit smaller than 8. Now we're approaching 8, but a little bit bigger than 8. It didn't end up mattering here that this was a little bit smaller than 8 over here, and this is a little bit bigger than 8 here. That's not going to be significant in this problem. When it does matter is when we're approaching 0. So number a little bit bigger than 2 going in for x here is going to give us a number a little bit bigger than 0. So we have a positive 8 divided by a number that's positive but really close to 0, and this is going to be positive infinity. So the left-handed limit is going to be negative infinity, right-handed limit is positive infinity, so this limit does not exist. Now, real quick, before I move on from this, I do want to tie this analytic problem to a graphical problem. If we think about what's going on here, what this means is if we're graphing, if we're plotting points here for this function, and we're plotting points that are approaching 2 from the left side, so as we approach the value of 2, but from the left, the numbers are becoming really large negative numbers. And what happens is we're going to get points that are getting, let me try that again here. We're getting really big negative numbers. And the closer and closer to 2 we get, the lower it's going to get on the y-axis. On the other hand, if we're approaching values of 2 from the right, the values that we get for our function are going to get really big, and we're going to be getting really big values. This may look familiar to you as an asymptote, and so this is going to happen anytime we have a 0 in the denominator without a 0 in the numerator. If it's 0 divided by 0, we'll talk about that in a moment, but we won't necessarily get an asymptote then. So graphically, when we get limits that are approaching negative infinity or positive infinity, we're going to be seeing asymptotes on a graph, at least when we're approaching a number. Later on, we're going to be looking at limits that approach infinity, and then all kinds of other crazy stuff might happen. So I want to clear this page here real quick and kind of go over some general rules. So as a rule, if we have a number in the numerator that is not 0, so c is not equal to 0. Let me start that over here. So let's say c is not 0. In this example, it was 8. If we have a limit that's c over 0, then there's 4 cases that we could get here. We could have a positive c value, so c is greater than 0, and we're approaching 0 from the right side. So we get a positive divided by a positive, that's going to be infinity. We'll keep c positive, but we approach 0 from the left side. Then we have a positive divided by a negative, and we get negative infinity. When c is a negative number, then we have a negative divided by a positive. It's going to be negative infinity. And we have a negative divided by a negative. Sorry, that should be negative. Negative divided by negative is going to be positive infinity. So we're just following the rules of dividing positive and negative numbers here. And what's really important is when the denominator approaches 0, we know whether it's a number a little bit bigger than 0 or a little bit smaller than 0. All right, this is going to go a little bit quicker here. In this example, only thing it changed is we have a minus on top instead of a plus. In this case, what happens here is we get 0 on top and 0 on the bottom. And in this case, if you remember, 0 divided by 0 is indeterminate. It's not undefined, although it is like if you plug that into a calculator, you're going to get undefined. But in terms of these limits here, this is indeterminate, which means we don't know. So this is the kind of problem that requires further analysis. So we might use trig identities, we might use conjugates to rationalize a numerator or denominator, or in this case, we can just use some algebraic manipulation using factoring. So we can factor the numerator as x plus 2, x minus 2. We recognize that x is not equal to 2, it's just close to 2, and that allows us to cancel. And then it's the same thing as the limit as x approaches 2 and of x plus 2, and that's just going to be 4. So if we get 0 divided by 0, we don't know what the answer is. It's not necessarily going to approach infinity, although it still could. So just one more example here. I'm going to keep it pretty simple. That's not where I wanted the square. So let's say we have x minus 2 over the quantity x minus 2 squared. In this case, we can cancel just like we did in the one above. The x minus 2 with one of the x minus 2's in the denominator. And we get this. And this goes back to the first example that I looked at. So we had 0 over 0. That was indeterminate. I did some algebraic manipulation, and we still get 0 in the denominator. But this time, the 0 in the denominator goes with a non-zero number in the numerator, and we're going to get this kind of stuff going on here. So we have to analyze one-sided limits. We're going to get infinite limits, either positive or negative infinity, based on whether the 0 down here is approaching from the positive side or the negative side.